Assalamualaikum and hello. My name is Muhammad Fairuz bin Muhammad Noor. My magnetic number is DE20095. So, in this video, our team will explain about off-grid photovoltaic system for a residential house using a manual calculation and software PV system. And we are from group 3. And these are our group members: Muhammad Harid Haikal, Muhammad Syafiq, Muhammad Ikram Daniel, Muhammad Fairuz, me, and Muhammad Afiq. So I will explain about introduction. For the first, the earth receives enough energy from the sun, and using solar energy to power electronic device start with converting solar energy into electricity. And solar energy, known as photovoltaic PV, convert into electric PV system can be used to use solar energy. And next, the grid connected and off-grid solar PV system can completely eliminate your power bill. And the lastly is cooler monosolar panel catch the sun's light and convert it to DC electricity.
Assalamualaikum and hi, my name is Muhammad Afiq bin Badrul Hisam. My matrix number is DE200125. Okay, today I will talk about the problem statement for our project. The problem statement for our project is we have to construct a power generation facility and the type energy used should be examined. So second is we have to choose a solar power charger that capable to provide enough power base on the yearly power consumption. And for Mr. Manisfu, we aim to identify the best solar off-grid system that can integrate with sunlight power charger as in-house house stable age model for single-story families. Okay, next is the objective. So we expect to give awareness to the people about our environment because our earth now is dying because of the pollution. So the objective of this project is we want to design off-grid PV system model that is renewable energy because we want to prevent pollution that occur on our earth. Second is we need to investigate the cost to design this PV model for construction for the residential house that belong to Mr. Manispu. And lastly is we are using the requisite electrical tariff, so we have to calculate average monthly cost of electrical energy for the electrical arrangement of the selected assembling. Okay, I think that's all from me. Thank you.
Okay, Assalamualaikum and hi. My name is Muhammad Syafiq bin Muhammad Nasri and my number entry is DE2072. Okay, today I want to present about the group project assignment that is PV system for the Mr. Ahmad Nisfu house. Okay, now I want to about the load calculation. Okay, we have the total power consumption for the Mr. Ahmad Nisfu house is 2075. Power consumption per day is 13.2 kilowatt maximum demand and total maximum demand. Okay, next for the load, you can see we get the TMD, total maximum demand 1.233 kilowatt, maximum demand 986, maximum current 6.3 ampere, size of MCB we get 7.9 ampere and we choose 20 ampere MCB SPN. Size of RCD 20 ampere, 30 milliampere for power circuit and 100 milliampere for lightning circuit. Okay, next for the wiring schematic diagram. This is wiring schematic diagram for the Mr. Ahmad Nisfu house. For the lightning circuit, this lightning circuit, and at the bottom is power circuit. Okay, after that, for the flowchart installation PV system, first the engineer must site visit to check the Mr. Ahmad Nisfu house to calculate the load analysis, and next choose the solar panel. After that, choose the battery bank, and then choose size inverter, and next choose for solar charger controller. After all the calculation, start the wiring work supervised by wireman. And if after inspection and testing, if something wrong, it will repair again, and then after all of the work, the payment and sign the contract, and the project is done. Okay. For the manual calculation, sizing of solar panels, we get from the power, PV power, we get the number of panel we use is 6. Sizing battery, we use 4 series batteries and 1 string parallel connection. After that, for the inverter, minimum inverter power is 2985 watt. We choose 3000 watt inverter. For sizing solar charger controller, is 5 number of series. Strings we use is one parallel connection, and ICC is 12.5 milliampere. Okay, I think that's all for me. I pass to simulation presented by Muhammad Haikal. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Haikal bin Muhammad and my meeting number is 10033 AE 10033. So I'm going to present for the simulation at the PV system 7.2. So this is the PV system. So the metro file is using the Kuala Lumpur, Subang. So for the orientation is 20 tile lead and azimuth is 0 degree. User needs is this as shows here, the same as we choosing what gonna have in the this section. So for the system, for the storage, we are using a LG channel, 51.4 volt, 295 milliampere hour, and one in series, 4 in parallel. So the capacity is 1186, and it has equivalent what are the storage we need in the manual calculation. For PV array, for the generic is 400 watt power and 32 volt. We're using a mono. So inverter, we use a MPPT converter, and the array design is 4 in the series, 1 in the string, so 1 in parallel. So here backup generator, we are using a 1.5 kilowatt. This is a simple sketch. So next we're gonna simulate. I already said, so we're gonna go to the report. So here the report. You can see here the project summary, system summary. So the PV characteristics I already talk about later. So this is daily user needed. This is main result. So the available energy per year is 2,300 kilowatt, and user need is 483 per kilowatt. So this is the loss diagram, and this the cost is 10,030 ringgit. So okay, that's all for me. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, I'm Muhammad Karunia Zainuddin. So I will continue the presentation for conclusion. So I list the 3 main points and I will describe each point. So in a nutshell, with rising energy bills and growing environmental concerns, households are looking for an alternative energy solutions. Off-grid photovoltaic system will pursue to provide basic daily necessities such as lighting, television, and radio in isolated villages, farming regions, and other remote locations. So for the second point, any medium to big home can benefit from an off-grid photovoltaic system. A house owner who install this system will never have to pay an energy bill again. So this off-grid PV system also is one that is not linked to the power grid, This means that's all of the energy generated is stored and utilized on the spot. Off-grid photovoltaic system work by using the energy saved throughout the day. And for the last point that I give for the conclusion is by during the day, off-grid solar system will generate extra power. This additional power or energy is sent to the battery to be stored. When the system isn't producing electricity, the energy stored in the batteries can be used at night or overcast days. Off-grid system can be sized to simply and enough access electricity to fulfill our energy needs for every second. So that's all from me. Thank you.